So when we talk about the history of artificial intelligence, we're not just talking about some recent tech trend. No, this is a story about a quest that's literally thousands of years old. It's this epic human journey to understand and maybe even create intelligence itself.
And to kick things off, maybe it's best to start with, well, a warning. This line from Mary Shelley's Frankenstein just perfectly captures the two sides of this coin, right? The incredible ambition and the potential danger. It's this powerful reminder that the dream of creating artificial life has always been haunted by some really deep questions about what we're unleashing.
And that brings us right to the heart of the problem. You can't just go out and build intelligence if you can't even define it. And honestly, that single question has stumped the greatest minds, philosophers, scientists, you name it, for centuries. It's the big puzzle at the center of this whole story.
Okay, so to really get our heads around this, we've got to rewind the clock. Way back. We're going to see how the intellectual seeds for AI were planted in ancient philosophy, long before anyone even had a word for computer.
Yep, believe it or not, this all kind of starts in ancient Greece. When you think about it, when Socrates was grilling people, asking for a clear standard to judge if an action was, say, pious, he was really asking for an algorithm for morality. He wanted a formal process, a set of rules to describe human reasoning. And that idea, the idea that thought itself can be broken down and described, that is the absolute bedrock of AI.
All right, let's jump forward a couple thousand years and see how that ancient question started to take shape in the modern world. Because it turns out that same philosophical puzzle created this huge split in how researchers even defined what they were trying to do.
So just so we're all on the same page, here's a good working definition for you. Notice it's not about what a system is, but what it does. If it acts in a way that seems intelligent to us, the observer, then we can call it AI. That's kind of our baseline for this whole thing.
And this is the big divide, the central philosophical choice. You've got two main camps. In one corner, you have strong AI. This is the big sci-fi dream, right? To build a machine that is literally a conscious thinking mind. But in the other corner, you have weak AI, which is way more pragmatic. It says, look, we can build programs that simulate intelligence really well to solve problems, but we're not claiming they're actually conscious. So one is a quest to build a mind, the other is a quest to build a really powerful tool that just mimics a mind.
Okay, but hold on, because here's a super important point, something you've got to keep straight. We need to separate the goal, are we building a mind or a tool, from the methods we use to build it. They are two totally different concepts.
See, in the early days, a lot of researchers were all in on weak methods. The dream was to create this one-size-fits-all logic engine that could solve any problem you threw at it. The thing is, they hit a brick wall, fast, and that led to this massive insight. Real intelligence isn't just about pure logic. It needs tons and tons of specific knowledge about the world. So the field shifted towards strong methods, systems that are jam-packed with information. And that realization, that knowledge, was the secret sauce. And that's what really unlocked all the progress we see today.
So before this whole quest could really get going, the pioneers needed tools. I'm not just talking about ideas, but the actual formal systems and the mechanical blueprints for computation. And man, did those take a long time to forge.
And this just shows you what a long, slow burn this whole thing was. You've got Aristotle inventing formal logic, then centuries later Leibniz dreams of a universal language for thought, then you get Boolean algebra, and finally Babbage with his engine. Each one was a critical piece of a puzzle that took, over 2,000 years to finally come together?
Let's just stop on Aristotle for a second, because his syllogism was a total game changer. It was a system where a conclusion had to follow from the things that came before it. It was like the very first operating system for pure reason, a formal structure for logic that's still humming away under the hood of so much today.
And then you have Charles Babbage. And this is it's mind-blowing. Back in the age of steam engines, this guy designed the analytic engine, a programmable mechanical computer. Think about that for a second. He created the blueprint for a thinking machine a full 100 years before the technology even existed to build one with electronics. That is some incredible foresight.
All right, so all the philosophical groundwork has been laid, the logical tools have finally been built, and now we hit the 20th century. The electronic computer is born, and the quest for AI officially finally begins. And it starts with a bang.
And the person who basically lights the fuse is the one and only Alan Turing. He's fresh off his legendary code-breaking work in World War II, and he drops the question that would define the entire field. Can machines think? But he didn't just ask the question, he actually came up with a test to try and answer it.
And the Turing test is just so beautifully simple. It totally sidesteps that messy philosophical debate about what thinking really is. Instead, it just tests for the appearance of thinking. Can a machine trick a human into believing it's human too? To this day, it's still this famous benchmark, and arguably, no program has ever truly, definitively passed it.
Now, I want you to look at this year, just this one single year. Because if this whole epic quest has an official birth date, it's got to be 1956. Because in the summer of '56, a bunch of researchers get together at Dartmouth College, and it's there that a computer scientist named John McCarthy gives this whole new field its official name, artificial intelligence. The quest was christened, the journey was on.
And what came next was just this explosion of optimism. I mean, these pioneers were predicting that within a few years, a computer would be the world chess champion, we'd have perfect machine translation. Their ultimate goal, their holy grail, was something called the General Problem Solver, or GPS, a single program that could solve pretty much anything. Looking back now, yeah, they might have been just a little bit optimistic.
So after that initial high, reality started to set in, a big dose of it. Researchers quickly found out that things like understanding language or just having basic common sense were way, way harder than they ever thought. And that early optimism kind of gave way to a new realism, a sense that this was going to be a very, very long road.
And this is where we see this really crucial pivot. That grand, sweeping goal of creating a single, human-like thinking machine, it was pretty much put on the back burner. And that shift was absolutely essential. By focusing on the more practical goals of weak AI, building specialized tools for specific problems, that's when researchers could finally start making real, tangible progress. In fact, that exact focus is what led directly to the AI that is changing our world right now.
And that's why the AI landscape today looks like this. That one great quest sort of fractured into dozens of smaller, specialized fields. You got machine learning over here, computer vision over there. All these are the modern descendants of that early work, and each one is tackling its own little piece of that giant puzzle of what intelligence actually is.
So that leaves us here with one final thought. This incredible quest, one that really started with Socrates, has given us tools that are completely reshaping our world. We have built machines that would have blown Charles Babbage's mind. But have we actually gotten any closer to answering the fundamental question that started this whole thing? Have we gotten any closer to truly understanding the mind itself? Now that's a question worth pondering.